Reeve, principal of Vanderveer Elementary School.
And I'm Dr. Tian, superintendent of schools.
We are so excited to welcome everyone to our Vanderveer Evening Learning Academy.
You are all in for weeks and weeks of enjoyment.
You will be learning alongside your very own Vanderveer teachers.
Also, we have teachers and administrators from across the district that will be bringing you fun learning experiences.
You will become scientists, engineers, mathematicians, writers, world explorers, and learn to communicate in different languages as you explore concepts in math, reading, writing, science, social studies, world language, and so many more.
Thank you so much for joining us tonight, and we encourage you to visit often and view other lessons in our learning library as we add to the videos each week. Enjoy!
What do you see when you look at this cloud? What about this one? And what about this cloud? Do you ever look at clouds in the sky and wonder how they got there? Today, we are going to apply our understanding of evaporation and condensation to create our very own cloud.
Hi, I'm Mrs. Chitundu, 6th grade science teacher at Somerville Middle School.
Hi, I'm Mrs. Hobbs, 6th grade ELA at Somerville Middle School. Hey, what are you doing?
Oh, nothing. I'm just checking out these really cool clouds in the sky. There's so many that come in so many different shapes and types and sizes. It's really fascinating.
It looks super cool. I'm wondering if we can make our own cloud right here in our very own laboratory.
I'm sure we can. Let's come over here and try.
Well, we know that clouds are an important part of the water cycle. Let's take a look at a model of the water cycle to see what processes are needed for cloud formation.
Looking at our model, we see that there is an arrow pointing upward labeled evaporation. It looks from the model as though water vapor is going up in the sky towards the clouds.
I wonder if our young scientists at home know what evaporation is. Do you know?
Okay, young scientists, now it's your turn. Evaporation is when water turns from blank to blank.
Good job. Evaporation is the process of going from liquid to gas.
Looking at our lab equipment here, what do you think we need to help turn liquid into a gas?
Okay, young scientists, what do you think? What do we need to turn liquid to gas?
That's right, we need energy in the form of heat.
So I have a beaker here sitting on a hot plate. I'm sure you all at home can see that as the water boils, there's steam that starts to rise off the top. After a while, the water vapor or steam seems as though it's disappearing into the air.
It does look like it's disappearing into the air, but we know that matter is not created or destroyed, that it doesn't just pop out of thin air or cease to exist. So that must mean that it doesn't disappear, but must become so small that we can't see it.
Yes, matter of any type can be subdivided into particles that are too small to see. But even then, the matter still exists.
Here we have another model showing us the changing states of water, from solid to liquid to gas. And when we look at the solid, we see that the water molecules are closer together. And as more energy is added to the system, we can see that the liquid water molecules are still there, but they are further apart. Same thing goes for the gas. As more energy is added to the system, the water molecules are still there, but as they separate and go farther apart, the less likely we are to see them with our naked eye.
So I wonder if that means there is water in the air even though we can't see it. I'm sure our young scientists at home know the answer. What do you think? Is there water in the air even though we can't see it?
Okay, young scientists, time to tell us what you think. Is there water in the air even though we can't see it?
Yes, great job.
So, I also know our young scientists at home might be wondering, if there's water in the air, what does that have to do with clouds in the sky?
Great question. We know that this hot plate provided the heat energy to cause water vapor. But where does the heat that causes water vapor to evaporate in the sky come from?
Okay, time to tell us what you think. Where does the heat that causes water to evaporate into the sky come from?
You've got it. The sun. The heat from the sun warms up the water on the ground, which causes the air to be filled with water vapor.
That leads us to our next step in the water cycle, condensation.
That's right, Mrs. Hobbs. The next arrow in our water cycle is labeled condensation, and it's labeled right above the clouds, which leads us to think that perhaps condensation is the process needed in order for clouds to form.
So, I also wonder if our young scientists at home know the change of matter taking place in condensation. Do you scientists at home know?
Okay, young scientists, now it's your turn. Condensation is when water turns from blank to blank.
Excellent. Condensation is the process of water turning from a gas to a liquid. But what is needed for condensation to occur? Well, if we need heat to cause liquid to change from liquid to a gas, what do we need to go back from a gas back to a liquid?
Okay, tell us what you think. What is needed to turn gas back to a liquid?
Good job. We need the opposite of heat, which is cold. When gas is cooled, it turns into a liquid. Here, let me show you.
So, what we have here is a nice cold glass of soda. And if you look close enough, you can see water starting to form on the glass. How do you think the water got there? Did it seep through the glass? Of course not. No water can pass through this glass. So, where is the water or where is the gas to make the liquid come from?
Once again, it's time to tell us what you think. Where does the gas that condenses on the glass come from?
Yep, you've got it. Water is in the air, in the form of water vapor, even though we can't see it with our naked eye. We know it's there because where else could the gas to form the liquid on this glass come from?
Well, that is pretty cool that we can see condensation happen on a glass jar. But what evidence do we have that the same thing happens in the sky?
Great question. Well, I did read somewhere that the temperature changes the higher up you go into the atmosphere. For our scientists at home, can you tell us whether the temperatures are warmer or cooler the farther you get into the air?
Well, I went hiking up a very tall mountain one day and I noticed that the temperature got much colder the higher we climbed.
Great connection. I'm sure our young scientists at home probably made a similar connection. The higher you get into the sky, the less energy is available. This decrease in energy causes the gas particles to slow down as they get closer and closer together.
So here we have an excellent model showing how clouds are formed. As you can see, the sun's heat beams down on the ground and starts to warm the air on the ground. Let's not forget that that warm air contains water molecules. And as you'll learn, warm air rises. So that warm air with those water molecules begin to rise up, up, up into the sky. And as it rises up into the sky, it starts to cool because remember, it's a lot cooler the farther you get into the air. So those water molecules start to cool, and because they cool, there's less energy, which causes them to slow down. Once they slow down, they start getting closer and closer together. And if you can remember from our last graphic, as water molecules get closer together, we're able to see them better. But when they spread farther apart, we're not necessarily able to see them with our naked eye. So as these water molecules start getting closer together, they start to rise, cool, and condense. And as you can also see in the model where the clouds are, the water molecules are closer and closer together. And those water molecules being closer together allows us to see them in the form of clouds.
So now that we know about evaporation and condensation, how do we use this information to make our very own cloud right here in our own laboratory?
Well, first we know that we need to start with water because we know that clouds are a part of the water cycle. Let's see if we can make a cloud that way. You know what, Miss Hobbs? I think maybe we can put some blue food coloring so that our kids at home can see the water.
I think that is a great idea and it's going to look super cool. Well, that didn't work. I wonder what's missing. Young scientists, do you know what ingredients we still need?
Think about everything that you've learned so far and try to think, what ingredient do we need to make a cloud?
Very good. We need water in the form of gas, which is what we call water vapor.
Yeah, so let's give it a try. So we'll just take some of this water that we already know is warm and we'll pour it into our jar. I see that we have steam coming from the jar, but we don't have a cloud. So that didn't really work that well. What else do you think we need, scientists?
Besides water vapor, what other factors do we need to make a cloud?
Great job. The water vapor needs to be cooled. We need to find a way to cool down the water vapor once it reaches the top. Let's try. Here's a lid with ice on it. Maybe we could try putting this on top to cool down the already heated water.
Well, we don't get a cloud, but we do start to see condensation on the side of the jar. I wonder what else is missing.
It seems like water vapor needs something to stick to. I wonder what water vapor sticks to in the sky. What do our young scientists at home think?
Tell us what you think. What do you think water vapor sticks to in the sky?
There are actually other smaller particles in the air other than water vapor that we can't see. Pollution, sea salt, and dust particles. All we need are some small particles that float in the air.
Those particles are called condensation nuclei. As you can see from this picture, condensation nuclei allows for water molecules to stick to it. As water molecules stick to the condensation nuclei, they also begin to stick to each other. And as you can see from this bottle, that the more water molecules begin to stick to each other, the bigger and bigger and bigger it becomes until you start to see a water droplet. These water droplets, when become so heavy, they can fall from the sky, and that's known as precipitation.
Hey, I have some hairspray. Maybe this could work. Let's give it a try.
Okay, so we have our warm water. Let's spray hairspray into the jar, put some ice on top, and see what we get.
It looks like a cloud is starting to form.
Yeah, it looks really cool.
Young scientists, do you see what we see?
Well, look at that. We made our very own cloud in a jar. Let's see if our young scientists at home can summarize everything we need to make a cloud.
Do you remember all of the ingredients needed to make a cloud? If so, what are they? Excellent. In order to make a cloud, we first need water vapor. Second, we need condensation. And we remember that condensation is the process of going from a gas back to a liquid, and we need the gas to be cooled in order for that to happen. And lastly, we need condensation nuclei. We need something for the water vapor to stick to or to condense onto to go from a gas to a liquid. Here is a model showing how the sun heats up the water on land surfaces and in the ocean, and how that warm air and water vapor rises up to the top of our atmosphere. As soon as it hits the atmosphere, that cold air meets the water vapor, and that water vapor condenses. That condensation is what leads to clouds. We really do hope you had fun with us as we applied our understanding of evaporation and condensation in order to explore how to make our very own cloud in a jar. We also hope that we encourage you to want to discover how to make your very own cloud at home. Some things you will need. Please make sure that whenever you do this experiment, you have adult supervision with you. You will also need hot but not boiling water, 1 jar with a lid, and ice. Also know that in our experiment, we included hairspray to represent condensation nuclei. This also can be done with a match. In order to be done with a match, you must first light the match and then blow the match out in the jar, allowing the smoke to fill the jar. Remember, the hairspray and the smoke represent condensation nuclei. So all you need is something for that water vapor to stick to. In all these things you do, please make sure, once again, that you are doing this with an adult. We hope you have fun making your very own cloud in a jar.